Okay, in this video what I'm going to cover is stuff about square roots, cube roots, and radicals. So let's just get it out of the way right now. A radical is literally that symbol. Now you're probably used to saying like the square root of 25, which is totally okay. Kind of like that. So if you were just like saying the square root of 25. But here's the thing that we don't always talk about is that there's a secret little 2 kind of ghost hanging out there, where mathematicians are just so lazy that they'd rather just write this symbol as opposed to including the 2 because it feels kind of like overkill for us. And I could make that 2 a different thing. So if I asked you about like the cube root of 64, I'm asking about something slightly different. So we're going to get into this kind of stuff. But this symbol is a radical. Here's the square root. Here's a cube root. That's what we're learning about today. So if you remember from a while ago, we had notes like this. You guys should have these notes somewhere else. They're also up in the Google Classroom if you want them. And we've spent a lot of time on exponential stuff. That was all of our loans and things like that. We've also spent a fair amount of time on linear stuff. We are going to spend lots of times on other things, but right now we're going to focus on the square root function, so this one right here. And there are so many things that we could learn about radicals. So why are we learning about this? What do we need to know? First, this one is called a radical. We want to know that you could do something like this. Also, we could learn about like, what do we do if we have 32 to the 5 halves? We might eventually ask ourselves, what would this function look like on a graph? What happens if you have a negative under the radical? And then what happens if you have like a 5? So this is the 5th root of 32. Lots of different things that we could learn about with radicals. Our goal here today, we're just going to focus on like this one, maybe this one. Yeah. Okay, one of the ways to look at these is to basically just look at some facts. So here are some pretty basic facts. And notice all I've got is I've got 2 factors of each of these. So 1 times 1 is 1, 2 times 2 is 4, etc. Another way to write these is to write them out as squares. So 2 times 2 is the same as 2 squared. 4 times 4 is 4 squared, or 2 factors of 4. That's really what we've got here, is that we have 2 factors of 4 is equal to 16. Okay, so here's what we're going to do. Just like multiplying and dividing are opposites, right? So you can go one way with multiplying and dividing. Same thing with like adding in one direction and then subtracting in the other direction. Something that we can do here, and what we're going to really focus on, is that if you have a number squared and then you have the square root of something, that is going to be going backwards. So here's what we've got here. The square root of all of these numbers. Notice the relationship between this pink column and this white column here. Oops, wrong thing. Is that if you have 2 factors of 3, that's 9. The square root of 9 is 3. So really what we've got here is like going forward, going backward. Square root of 25 is 5, because 5 squared is 25. So these things, they're kind of like saying I have the same relationship between the pink and the white as if I said like 2 times 5 is 10, and 10 divided by 5 is 2. They're different equations, but they give me the same kind of relationship between numbers, right? So forwards, backwards. And then what I want to show you is that there's another way that we could actually write this out. And that is by saying something to the 1/2. What? We'll get into this in a second. But the square root of 9 is equal to 3 because this is like 1/2 factor of 9. So here's what I want you to focus on, and let's really hone in on this line right here. If I said I want the square root of 9, y'all would be like, cool, it's 3. And the reason is 3 times 3 is 9. Okay, so if I say I want 1/2 factor of 9, one thing you could do is write this out as 2 factors, right? Right, 9 is 3 times 3. If I want one of those 2 factors, I want one of these 2 factors, that also ends up being 3. Let's dig into that a little bit more. Okay, so here's a question. Why do we call them square or cube roots? And here's really why. if this right here is a square, and I say, for sure, this thing is a square, and I tell you this side is 4 feet long, is it possible that this side is 3 feet long? No, of course it can't be possible that that would be 3 feet long, because if it's a square, they have to both be the same, and you'd get that the area inside here is 16 feet squared. Okay, so if I asked for the square root of 16, that's kind of like me saying if I had a square that was 16 area, what would the side length be? It would be 4. So that's why we call it a square root. The same thing happens with this idea of a cube root. So if I have a cube, like this, a three-dimensional, well, the volume of a cube is length times width times height, so like pink times purple times orange, so 2 times 2 times 2. That means that I really have 3 factors of 2, and the cube root of this is gonna end up, sorry, I got too many things here. So what we've got is that 2 cubed, or 3 factors of 2, is equal to 8. And we could write that then as the cube root of 8 is equal to 2, which is the same thing. So these two things say the same equation, where you've got the cube root of 8 is 2, or 8 to the 1/3, which again, kind of like we just talked about, if I have 3 factors here, and I know that 2 times 2 times 2 is equal to 8. If I say, write 8 as 3 different factors, and I want one of those 3 factors, then I would just take the 2. So 8 to the 1/3 is 2. Same stuff is happening over here, where let's say I had an area of 25, and I said, what's the side length? Well, because 5 times 5 is 25, this says the same thing as 5 squared is 25, or that the square root of 25 is 5. So again, because 2 factors of 5 gets you 25, if I wanted one of those 2 factors, I would just end up getting 5. So the idea being that if you write a square root, or if you write to the 1/2 power, they're the same. Same thing over here if you have a cube root and the 1/3 power. You could also do a 4th root and a 4th power, etc., etc. Let me know what questions you've got. If you are okay seeing like why these 2 equations say the same thing, then you're in a pretty good spot for us right now.